Okay, we'll now take on the OR question. Alright, figure 11.1 is scale diagram of a converging lens, object, and real image produced by the lens. Okay, three rays are shown from the top of the object. Okay, define focal length of a converging lens. Alright, this one you should have it memorized. Okay, it's distance between the optical center and focal point. And the reason why I add another line behind is because it's a 2-mark question. So I'm very suspicious when it's 2 marks and then I give a 1 line like that. Okay, I'll think that it's a little bit for 2 marks. Alright, so I'll actually probably try and explain focal point as well. Okay, the focal point is the point where rays parallel to the principal axis converge after passing through the lens. Okay, please spell this in full. Okay, apologies for the short form. Alright, moving on, complete 11.1 by continuing 3 rays from the top object until they meet the image. Right, so this is something that you should already be able to do very well. So I trust that C11s can do this, right? You just extend the line appropriately, okay, and you should be able to find the principal focus, right? So mark it out with capital F, right? So remember to follow instructions, mark it out with capital F here. Okay, so not much to discuss about this, right? This is a graph of how the image of the lens varies with the distance of the object from the lens, right? So if you look at this graph over here, the question is the distance of the object to the lens is equal to the distance of the object to the lens is equal to the distance of the image to the lens. Alright, use the graph to determine the distance of object to the lens. So they're asking you when is the object distance, right, equal to the image distance, right? So you can just check lah. Okay, so let's just look at the graph bit by bit, right? So you don't have to worry too much if you see an unusual graph. Just try and decipher it. So when the image distance is 160, the object distance is about 20 something, right? So clearly not the case, they're not equal. Then you just look down and realize that it's 60, image distance 60, object distance 30, right? So not correct again, but you see here image distance 40, object distance 40, right? So this is the answer we're looking for, right? Distance of object to the lens when this happens. Okay, using your answer to C part 1 and the scale diagram in 11.1, determine the focal length of the lens. Right, the answer to this is 20. It doesn't come from the graph, right? It comes from understanding where this, what this 40 means in the context of your lens table in the textbook. Right, if you don't know what I'm talking about, you open your textbook, turn to page 242. Right, there you have the lens table. Okay, if you are my student, right, I'll probably make you draw the lens table with a closed book, just a blank piece of paper. That means I make you sort of be able to produce the whole lens table by yourself, right? So that essentially in the exam you can replicate that. You realize that the only time the object distance equal to the image distance, as per this question is asking, is when the object distance is equal to 2f, right? Which is the third row. Okay, so in that table in page 242, you realize the first line is u equal infinity, then u greater than 2f, right? That means the object is beyond 2f away from the lens, and then u equal to f. And u equal to f is the only diagram that shows you that the object distance is equal to image distance. Right before this, when u is infinity and u is beyond 2f, the object distance is greater than image distance. And after u equal to f, generally the opposite is true lah. You can see that object distance becomes smaller than image distance. Of course, there are exceptions in the last two cases lah. Okay, so there's only one answer, and that is when you are able to identify that u equals to f is the case of this one. Right, so that means the object distance is equal to 2f. So what is f? F is 20 lor, because the object distance is 40 ma. Right, so f must be 20. Okay, right, moving on. If I move the object to obtain a new image and it is real and larger than the object, again, if you are able to sketch the ray diagrams, right, of everything on page 242 on yourself, you'll be able to tell what are the conditions for you to produce a real and larger than object diagram. That means the image is larger than object, right? So the only cases when the image is larger than object is after the 2f case, right? So after 2f, you realize that when u is between f and 2f, the image is larger than object and is real, right? At u equal f, I stress again that actually there's no image because it's parallel. Okay, so in this case, I disagree with the textbook which says that the image is upright, virtual, and magnified. Okay, at u equal f, there is no image because the lines are parallel. There's no way to meet. Okay, so the last one, image is bigger than object, however is virtual. Okay, so u smaller than f is not correct. So the answer to this case must be the object is between f and 2f. Right? So that's why the object is between one focal length and two focal length away from the lens. Okay, finally, three characteristics of image produced when the distance of the object to the lens is smaller than the focal length. Right? So they're asking for u smaller than f, right, which is the magnifying glass case, right, which is the last column in your textbook. Okay, so it should be very straightforward. Okay, virtual magnified, all right. Okay, so this is a free 3 mark over here.